Write all the geometrical isomers of ting tang and how many of these will exhibit optical isomerism. What is ting tang? It is PT. Now A, B, C, D. Something like this. 4 different monodentate ligands. Please note, platinum plus 2 and palladium plus 2 with D8 configurations, they would be simple planar. I mean, in each of these cases, let me solve this nicely and neatly for you. I think you will discover this. It contains platinum plus 2. Electronic configuration of platinum plus 2, if you see, it is 5D8. And it is a low spin complex. Why? Because second and third transition series, they always give you a low spin complex only. Coordination number is 4, so I just take 4, so DSP2. The hybridization in this case, my dears, is DSP2 and the associated geometry is square planar. And the moment geometry becomes square planar, now there is a problem. What? Since it is planar, that plane itself would be the plane of symmetry. Yes. So the question is, how many of these will exhibit optical isomerism? The answer is none of these will exhibit optical isomerism because every molecule is going to be a chiral or non-chiral. Fine. Second half is answered. None of them, 0 of them will exhibit optical isomerism. But how many geometrical isomers? Let's try. I mean, it is just going to be a square planar complex. So all I need to do is just to make squares and write down how many different permutations, combinations I actually get. Okay, that's cool. PT, PT, PT. Now, if I write down A, do you see that these locations are cis, but the opposite location is trans? There are 2 cis locations with respect to A, but only 1 translocation. So A, on translocation I write down B or C or D. A, B, A, C or A, D. Fine. Similarly, if I find B, trans to B is A. Yeah. If it is AC, the remaining portion would be BD. I just dump BD here, I just dump CD here in any order, and I just dump AD to BC here. And let me start seeing. Now, on the translocation of A, I could have had B or C or D. Is that done? Yes, that is very neatly and clearly done. On translocation of B, I could have had A, I could have had D, I could have had C. B, C, D, only 3 options. All 3 are met. Trans to C, I could have D or A or B. Trans to C could be A or B or D. I already have it. Trans to D could be C or B or A. I have it. Is that it? That is it. A maximum I could have is 3 geometrical isomers. Instead of A, B, C, D, just write down A as ammonia, B as bromide, C as chloride, and D as pyridine. That's it. I have 3 geometrical isomers and 0 optical isomers. That is the answer.